Okay, for this problem, we're going to determine the amount of heat that we need to add to copper to change it a certain length. Um, but a couple of things that we don't know is we don't know what is the mass of the copper. We also don't know the change in temperature, but we have formulas to determine that. Remember, we have the MCAT formula. It gives us the amount of heat that we need to determine, but we don't know the mass and we don't know the change in temperature. However, we can use density formula, which is rho equals mass over volume. And we can also use the change in length formula or the linear expansion formula to figure out the change in temperature. So if we just start by doing the density formula, we know mass is density times volume. It gives us the density of the copper, which is 8,960. It also gives us the volume. It tells us that it has an area of 0.005 with a length of 5, which tells us that the mass of this copper is 22.4 kilograms. Now go over to the other side where we're going to determine the change in temperature. We have to do a little algebra. So the change in temperature is equal to the change in length over the alpha L0. Tells us the change in length is 0.5 centimeters, so make sure that you convert that into meters just by putting 10 to the negative 2. It tells us the alpha is 1.7 times 10 to the negative 6. And that the initial length was 5 meters. And it tells us, that gives us gives us a change in temperature equal to 58.8 Kelvin. And now we can take these two numbers and these are the two numbers that we need for our heat formula. So we got Q equals mass, which we know is now 22.4, times C, which is 385, times our change in temperature, which is 58.8. Now remember, with the change in temperature, you don't need to convert, because remember that, excuse me, that change in temperature, a change in Kelvin is a change in Celsius. So you don't need to convert, even though in our previous equation it gave it to us, the answer will be in Kelvin. So the amount of heat that we need to add is 5.1 times 10 to the 5th joules. So there's our answer. Also be careful, question may ask you for calories, kilojoules. Just remember the different conversion factors. In one of the practice videos, it gave you the conversion factor for joules to calories and calories to joules. So just again, pay attention to what they're asking.